What if I told you NASA is tracking an object from another star system that breaks all the rules of physics? On July 1st, 2025, astronomers discovered something impossible: an interstellar visitor moving with surgical precision through our solar system. Its trajectory isn't random, it's precisely visiting Venus, Mars, Earth, and Jupiter in sequence. Its timing isn't coincidental, appearing just as our technology became capable of detecting it, and its behaviour isn't natural, showing characteristics of both comet and spacecraft. The probability of this happening by chance: 5 in 100,000. Some astronomers are quietly asking the question nobody wants to voice. What if it's watching us? Astronomers trust the sky to obey its own laws. When something comes from interstellar space, it should obey 3 rules. Rule 1, its path must be random. A cosmic drifter has no reason to weave precisely through our planetary system. Rule 2, its timing must be coincidence. Billions of years pass without visitors. Why should one appear just as we look up with new eyes? Rule 3, its behaviour must be ordinary. Rock or ice, asteroid or comet. Nature doesn't improvise. On July 1st, 2025, an object broke all 3 rules. And here is where we begin. Most channels would make shallow remarks with no substance or facts. But we don't do that here. We follow the patterns others overlook, we connect the anomalies others dismiss, and we read a damn lot about it. The story of 3i Atlas isn't just about astronomy, it's something more. So before we go deeper, thank you for clicking on this video. It began quietly, in the desert night above Chile. The Atlas Survey Telescope was built to protect us, scanning for asteroids that could strike Earth. Its job was simple: spot threats before they spot us. On that morning, it found something else. A dot of light, barely brighter than the background stars. The system assigned it a provisional tag, one of those alphanumeric strings that mean nothing outside a database. Another whisper among millions. But then came the first calculation. The speed was wrong. 61 kilometers per second relative to the Sun. Far too fast for anything born here. A second calculation confirmed it. Then a third. The orbit wasn't a curve, not a loop around our star. It was a hyperbola. This thing wasn't from the solar system, it was passing through. The word spread quickly, phones lit up, observatories pivoted their gaze. By the next morning, the cold provisional code was gone. A new name emerged, one destined to be remembered. 3i Atlas, the third interstellar visitor ever confirmed. Oumuamua had been the first. A cigar-shaped shadow that sailed silently past in 2017, tumbling so strangely that it was compared to a sliver of technology. Then came Borisov in 2019, a classic comet in every way except origin. Both had left us with questions. But this one was different. The deeper the astronomers looked, the stranger it became. The first clue was the trajectory. Natural objects wander in. Their paths are chaotic, shaped by chance encounters with stars and gravity wells. But this one didn't wander. Its course sliced through the solar system with unsettling precision. Close approaches to Venus, Mars, even Jupiter. As if it were following an itinerary. The probability of a random comet hitting these alignments, about 5 in 100,000. Small enough that people muttered words they usually avoid. Impossible, deliberate. The second clue was the timing. For billions of years we would never have known it was here. Our telescopes weren't sharp enough. The Atlas survey itself had only recently come online. And yet, at the exact moment our species achieved the tools to. The third clue, it was its behaviour. At first it looked inert, like an asteroid. Cold, solid, silent. But as days passed, telescopes began to see something else. A thin coma, a veil of gas and dust, faint but undeniable. Not quite a comet, not quite a rock. A hybrid, a disguise. 3 broken rules, 3 alarms, trajectory, timing, behaviour. The scramble began. Astronomers dug into archives, hunting for pre-discovery images. The Zwicky Transient Facility had seen it in June, maybe even in May, but the dense star fields of the galactic centre had hidden it. Only when it crossed the right patch of sky, only when 3i Atlas was awake and watching, did it reveal itself. The James Webb Space Telescope was turned toward it. On August 6th, its infrared spectrograph captured the composition of the coma: carbon dioxide, water, a hint of carbon monoxide, ancient chemistry, but arranged in ways that raised more questions than answers. What was it hiding beneath that shroud? Some astronomers dismissed the alarm. A comet, they said, nothing more. An interstellar fragment, torn from its home system, wandering for eons until chance carried it here. But the coincidences piled too neatly for others to ignore. A path like reconnaissance, a timing like choreography, a behaviour like misdirection. And quietly, in observatory offices and late-night message threads, the whispers began. What if it wasn't just passing through? What if it was watching? Imagine the scene on that first night. A graduate student double-checking a velocity that refused to shrink. A supervisor jolted awake by a phone call. A room full of astronomers watching the trajectory resolve on their screens, each calculation making the object stranger, not simpler. Every new fact added another weight to the mystery. Every correction made the orbit sharper, the impossibility clearer. By July 2nd, it was official. This was interstellar. By July 3rd, it was unavoidable. This was anomalous. The case file thickened hour by hour, a detective story written in light curves and orbital mechanics. But the facts were not enough. They were the first steps toward a revelation that hovered just out of reach. What is this thing? Why does it move with such purpose? Why now, in this fleeting chapter of human history, when our eyes are just sharp enough to notice? The answers remained in shadow, but one question grew louder with every passing night. What if it isn't here by accident? That thought lingers because the deeper scientists looked, the less sense it made. And that brings us to the trajectory problem. The orbit of 3i Atlas is not just strange, it is impossible. Every new observation tightens the line, every calculation confirms the same result. It does not drift. It cuts. It moves with a precision no random interstellar wanderer should possess. And the more we track it, the clearer it becomes. This object is not just passing through the solar system, it is moving through it like it has a destination. Its eccentricity is 6.14, the highest ever recorded. To the public, that number is meaningless, but to astronomers, it is terrifying. Oumuamua was 1.2, Borisov was 3.4. Both bent to the sun's pull, even if only slightly. But 3i Atlas refuses to bend. It streaks across the solar system as if gravity itself barely exists, as if the sun is nothing more than a lamppost on the side of a dark highway. And then there is the speed, 61 kilometers per second relative to the sun. At that velocity, Earth cannot catch it. Jupiter cannot capture it. The combined gravity of the solar system cannot hold it. It is faster, sharper, more precise than anything we have ever seen. This is not an orbit born from chaos. This is a line drawn with intent. Astronomers have run the models again and again, hoping the numbers will change. They don't. The eccentricity holds, the velocity holds. The path slices clean through the planetary system, too straight, too confident. Natural comets wander. They loop, they meander. 3i Atlas does none of this. Its trajectory looks less like the footprint of a rock and more like the flight path of a machine. Oumuamua looks strange. Borisov looked familiar. This one looks deliberate. Scientists keep offering natural lifelines, desperate to bring this thing back into the realm of chance. Maybe a gravitational kick ejected it from its home system. Maybe a passing star bent it this way. Maybe it is just one of countless fragments drifting unnoticed until now. But each explanation breaks under the weight of the numbers. There is no plausible chain of encounters that would fling a body onto a hyperbola this extreme without scars, without evidence, without chaos. And that is the problem. Chaos is missing. 3i Atlas moves like it knows where it's going. Its orbit slices through the plane of the planets at just 5 degrees off the ecliptic, almost parallel, almost aligned. Wanderers don't do that. Wanderers arrive at wild angles, plunging in and out of the system like drunks stumbling through a doorway. It steps inside like it belongs here. This is why the whispers began. Scientists don't say probe in public. They use words like unusual, remarkable, anomalous. But behind the scenes, in late-night calls and encrypted threads, the word is unavoidable: probe. Because what else moves like this? What else carves a line across billions of kilometers with such indifference to gravity? What else treats the solar system like a waypoint, not a prison? Imagine being in the observatory when the orbit diagram appeared. The first fit of the data, the line too sharp, the curve too clean. Graduate students staring at screens, recalculating over and over, praying for error. Supervisors jolted awake by phones, hearing the same impossible number from multiple observatories at once. Mars in October, Venus in November, Jupiter in March. A sequence too neat to be dismissed as noise. 3i Atlas is not a comet like Borisov. It is not a tumbling shard like Oumuamua. This one is different. It is precise, it is fast, it is aligned, and it is here now, writing its message in the language of orbital mechanics, daring us to translate it. The question is no longer whether this object is interstellar. That is certain. The question is why it moves as if guided, why it ignores the chaos of chance, why its path resembles not exile but itinerary. And if there is an itinerary, then who wrote it? Mars will be first. On October 3rd, 3i Atlas cuts past the red planet at just 28 million kilometers. In cosmic terms, that's a hair's breadth. Mars has watched comets before, harmless, forgettable streaks across its thin sky. But it is not just another comet. Its coma is already glowing, its plume defying expectations, its chemistry unlike anything our instruments should be seeing. And now, for the first time in human history, another world will witness an interstellar object skim so close it might light the Martian night. The orbiters around Mars, MAVEN, Odyssey, Perseverance's relay craft, they all have a chance to see it. Some engineers whisper about redirecting cameras, capturing data, anything to preserve the moment. But there is fear too. What if the proximity reveals something unexpected? What if this object is not passive? From Mars, 3i Atlas will dive toward the Sun. It will reach perihelion on October 29th, sliding to just 1.36 astronomical units, threading the gap between Earth and Mars. At that moment, its speed peaks, 68 kilometers per second, the highest velocity of any interstellar visitor ever tracked. Not even Oumuamua dared move this fast. Not even Borisov burned this hot. Velocity is energy. Velocity is intent. 3 days later, it brushes Venus. 97 million kilometers may sound like safety, but orbital mechanics sneer at human comfort. Venus is the solar system's great mirror, a planet wrapped in cloud, reflecting sunlight like a beacon. If you wanted to use a planet to signal, to announce your arrival to any watching intelligence, you could do worse than Venus. And there it will be, sliding past, casting its veil of dust and gas against the brightest reflector in our skies. Coincidence. The word grows weaker each time the object checks another box. Mars, the Sun, Venus, a sequence like choreography, a path that looks less like an accident of physics and more like a demonstration. By December 19th, it will pass Earth. Not close enough to strike, not even close enough to graze our moon, but close enough to watch. 268 million kilometers, far to our eyes, but to the mathematics of the cosmos, uncomfortably near. If this were a reconnaissance mission, this would be the moment. Our telescopes trained on it, our satellites buzzing with anticipation, the entire scientific world awake and watching. And above us the comet will slip silently by, its coma swelling, its gases outgassing in patterns we barely understand, as though leaving us a riddle written in light. But the itinerary does not end there. In March 2026, it makes its closest approach to Jupiter, just 54 million kilometers from the gas giant's swirling storms. Jupiter, the great gatekeeper of the solar system, the planet whose gravity defines so many destinies. Oumuamua never went near it, Borisov never touched it, but 3i Atlas. This one aims straight for it, like a pilgrim approaching a shrine. The sequence is undeniable now. 4 encounters, 4 cosmic markers: Mars, Venus, Earth, Jupiter. The odds of such alignments by chance? 5 in 100,000. The odds of it happening twice, with this precision? Astronomers have stopped running the numbers. At some point, statistics become an excuse, a way to hide from the possibility staring you in the face. And this is where the fear begins to sharpen. Not fear of collision. This comet will not strike us. The fear is subtler, stranger. Fear that we are not watching an accident, but a maneuver. That the visitor is not drifting on a trajectory, but following one. That these encounters are not chance alignments, but waypoints. If it were reconnaissance, this is exactly how it would look. Skim one planet, swing past another, measure atmospheres, magnetic fields, chemical traces, use gravity not just for speed but for data, and all the while never too close, never threatening. A silent overflight, a survey. Scientists resist saying this aloud, but the whispers persist. The comet is behaving like a probe. Its path is too clean, its sequence too deliberate, its speed too high to belong to chance. And yet every telescope confirms the same thing. The comet is real. The gases are real. Carbon dioxide, water, carbon monoxide, dust. To all appearances, it is a comet. And maybe that is the cleverest part of all. If you wanted to hide something artificial, if you wanted to cloak it in the trappings of nature, what better disguise than a comet? A shroud of ice and dust, a tail of particles trailing into space, every signature screaming natural, until you look closer, until the trajectory itself gives you away. That is why the debate rages. Some call it paranoia, some call it science fiction, others look at the numbers and feel the weight of inevitability. 3i Atlas is different. It does not just break rules, it breaks patterns. It refuses to behave the way nature says it should. And that refusal leaves us with only 2 choices: dismiss the anomaly, or confront the possibility that something out there is watching. Picture it now. Mars in October, glowing faintly as the comet sails overhead. Venus in November, the comet's veil sliding past its shrouded face. Earth in December, telescopes strained, citizens unaware. Jupiter in March, storms boiling below as the object traces its final marker before vanishing back into the void. A clean sequence, a map drawn in space, a message written not in words, but in motion. 3i Atlas is not just a visitor. To many, it is an announcement. The first thing to understand about timing is this: interstellar objects are not supposed to care about us. They move on paths set millions or billions of years ago. If one happens to swing past Earth while our species exists, that's luck. Blind chance. Nothing more. But 3i Atlas arrived in 2025, and that is not just any year. Go back a century. In 1925, no human had left Earth's atmosphere, no radio signal strong enough to leak into space. To anyone watching from the outside, Earth was silent. A planet with oxygen and water, yes, but no noise, no machines, no evidence of mines. Fast forward to 1945. Detonations of the first nuclear weapons send out unmistakable gamma-ray signatures, detectable across interstellar distances. For the first time in Earth's history, a civilization here leaves an unambiguous mark on the cosmos. The planet now hosts intelligence capable of splitting atoms. A signal to anyone listening that a species has reached a dangerous threshold. By the 1960s, Earth surrounds itself with satellites, radar pulses, television broadcasts, military transmissions, deep space tracking signals. A shell of electromagnetic leakage expands outward at the speed of light, announcing our presence to every star within a 60 light-year bubble. And then, 2016, Atlas, the survey telescope network, comes online. Humanity finally gains the technology to see faint objects sweeping through the solar system. Before 3i Atlas, Oumuamua might have passed unnoticed, Borisov maybe. But with Atlas network watching, nothing that cuts across our skies at magnitude 18 or brighter can easily escape. And in 2025, just 9 years after the telescope switched on, the object that bears its name appears. Not just any interstellar object, the fastest, the most eccentric, the most precisely aligned of the three we've ever seen. Coincidence? That word doesn't hold steady for long under scrutiny. Because think about the timescale. If 3i Atlas has been travelling for billions of years, what are the odds it arrives now, in the narrow sliver of human history, when our species has both the capability to notice it and the vulnerability to be changed by the knowledge? Astronomer Darrell Seligman put it bluntly when Oumuamua passed. The probability of observing one interstellar object in the decade we had the right instruments was vanishingly small, and yet we have now seen 3. Oumuamua in 2017, Borisov in 2019, 3i Atlas in 2025, 3 in less than a decade, after billions of years of silence. Some scientists argue that this proves interstellar debris is common, that our galaxy is littered with fragments, but others notice something else, the clustering. Why now? Why, after eons, do we suddenly stand at a window where visitors file past almost in sequence? And more unsettling still, only this one comes with a trajectory that looks choreographed. Oumuamua tumbled erratically. Borisov behaved like a comet, outgassing, fragmenting. This comet alone moves with precision, threading planetary encounters like beads on a string. So what do we make of this timing? One possibility: it's random, and our pattern-seeking minds are inventing meaning. But step back, take Earth's timeline as a whole, and the alignment is harder to wave away. For 4 billion years, Earth was mute. Then, in just the last 100, it screamed into the void with nuclear fire and radio noise. Within that same span, telescopes capable of spotting interstellar visitors switched on, and in that exact sliver of history, 3i Atlas arrives. If you were watching Earth from afar, waiting for a signal that its inhabitants had crossed a threshold of technology, 1945 would have been your marker. If you wanted to arrive when they were able to notice you, but not yet strong enough to resist or control the encounter, 2025 would be ideal. Early enough to shape us, late enough to be seen, and here is where the detective story deepens, because the arrival is not just about years, but about seasons. October. That is when 3i Atlas sweeps past Mars and rounds the Sun, and October is when Earth itself is blind. Every year, Earth's orbit carries us behind the Sun relative to our galactic neighbourhood. Telescopes lose part of the sky, cut off by glare. For a few weeks we cannot see what comes from that direction. Oumuamua used the same trick. It emerged from the October blind spot, slipped past before we even noticed. By the time telescopes locked on, it was already leaving. 3i Atlas repeats the manoeuvre, approaching from the galactic centre, crossing through dense star fields where no automated survey could easily pick it out. It emerges into view only when it is practically upon us. If it had arrived months earlier or later, we might have caught it sooner, tracked it longer, perhaps even prepared. Instead, it chose the exact geometry of our blindness. That is why some astronomers say the word they hate to say, deliberate. Not because the physics demand it, but because the sequence of coincidences collapses into a pattern. Think of reconnaissance on Earth. A plane does not fly past when the skies are clear and defences awake. It chooses cloud cover, nightfall, blind angles in radar. It comes when it can see without being seen. So we circle back to the question, why now? Why this decade, this month, this geometry? 3 broken rules already mark it: the trajectory that threads planets, the behaviour that shifts between asteroid and comet, and now the timing. Coincidence piled on coincidence until it bends under its own weight. In conference halls, scientists tread carefully. They present data on eccentricity, on orbital inclination, on gas emissions. They avoid words that break careers: intelligence, intent, design. But in quiet conversations, the question rises like static. What if the timing isn't coincidence at all? What if 3i Atlas is here not just to pass through, but to arrive at the exact moment we were ready, and vulnerable to notice? Patterns are the enemy of coincidence. 1 anomaly can be dismissed, 2 can be explained away. But when timing itself becomes a sequence, even skeptics grow quiet. It arrives after Oumuamua and Borisov, completing a trio of interstellar visitors within less than a decade. Astronomers have tried to make this cluster ordinary, suggesting that interstellar debris is far more common than expected. Perhaps, they argue, it is only our new telescopes that make the universe look busy. But that argument collapses against the details. Oumuamua passed unseen until it was leaving. Borisov burned bright but natural. Only 3i Atlas arrives with a path that looks like it was planned, a trajectory that threads planetary encounters with uncanny precision. Timing and trajectory together create a sharper question. What if the solar system is not just being visited, but surveyed? Think like an observer. If you wanted to study a young civilization without contact, how would you do it? You would not park in orbit, where detection is inevitable. You would not land, where contamination is certain. You would pass through at a distance close enough to gather data, far enough to remain untouchable. The sweep would be fast, efficient, deniable, and above all, it would come at a moment when the target was advanced enough to be worth watching, but still vulnerable, early in its technological adolescence. That is exactly where Earth stands now, capable of noticing, incapable of responding. A species that can calculate TLAS's orbit, but cannot alter it. A species that can suspect intent, but cannot prove it. The coincidence sharpens further when you align this comet's passage with Earth's own calendar of visibility. October, our blind season, when the sun blocks part of the sky. Both Oumuamua and 3i Atlas exploit this geometry, appearing only once the chance of early detection has closed. Astronomers hate calling this deliberate, but the parallel is hard to ignore. It is reconnaissance logic in its purest form. Arrive through the blind angle, leave before defences align. Even the perihelion date raises eyebrows. October 29th, 2025. The precise moment when Earth and Mars align in their orbits, when observation from 2 planets is possible. For decades, planetary scientists have dreamed of dual station measurements, 2 worlds capturing the same phenomenon at once. Atlas delivers the opportunity by accident, or by design. Step back again. For billions of years, Earth was mute. Then, in a single century, it announced itself with nuclear fire and radio noise. Within that same century, telescopes capable of tracking interstellar objects switched on. And in that exact window, the comet arrives, following a path that makes sense only if seen as a survey. This is why the word coincidence begins to fail. The probability of 3 interstellar objects appearing in under a decade is already vanishingly small. The probability of one of them following a trajectory that mimics reconnaissance, exploiting blind spots, aligning planetary encounters, brushing near Earth within observational range, shrinks further still. At some point, coincidence becomes choreography, and choreography implies intent. That is the unsettling weight pressing down on astronomers now. Publicly, they describe 3i Atlas as unusual, puzzling, extraordinary. Privately, some admit what the pattern suggests. This is not just an object, it is an event. It has arrived at the exact moment our civilization reveals itself, and it is moving as if that revelation was the point. The pattern forces one last question, the hardest of all. If this object is following a schedule, then who set the clock? Because timing is not passive, timing is chosen. And the numbers force one conclusion. 3i Atlas behaves like an observer. So the question becomes, if it is watching, what is it watching for? From outside our solar system, Earth is not a globe of continents and oceans. It is a thin spectral fingerprint. Oxygen, methane, water vapour, ozone. A trained eye can tell immediately that this is a living world. For billions of years, that signal has drifted into space. But life alone does not draw attention. Biology is common. Intelligence is rare. And in the last century, Earth crossed that line. The transition is clear. For most of its history, our planet's light was silent, its chemistry stable. Then came the 20th century. Nuclear detonations flashed against the background. Radio signals surged outward. Radar pings bounced off the Moon and Mars. Industrial chemicals altered the atmosphere in ways that cannot occur naturally. Anyone watching from the void could pinpoint the exact decade when Earth ceased to be only a biosphere and became something more, a technosphere. To a probe like 3i Atlas, this is the critical threshold. A planet with life is interesting. A planet with intelligence is strategic. Intelligence means unpredictability, potential expansion, potential threat. It means the planet is no longer background. It is a variable that must be monitored. And Earth is easy to monitor. Every satellite launch is a beacon. Every missile test is a flare. Every broadcast, every radar sweep, every thermal signature from power plants, cities, even fishing fleets. Each one is a breadcrumb leading back to us. This is the logic of surveillance. You do not need to reveal yourself to understand. You do not need to interfere to control the picture. You only need to observe long enough, carefully enough, until the target explains itself. Its trajectory fits this model. It does not stop, does not orbit, does not signal. It passes quickly but precisely, skimming past Mars, Venus, Earth and Jupiter in sequence. Each encounter provides a laboratory, atmosphere sampling, magnetic field measurements, gravitational tests. With nothing more than passive instruments, a probe on this path could collect a complete dossier on the solar system's conditions, and on the civilization inhabiting one fragile world. Reconnaissance has its rules. Rule 1, do not be noticed. Rule 2, if you are noticed, be deniable. Rule 3, always leave more questions than answers. 3i Atlas follows all three. To most, it is a comet. Its thin veil of gas enough to mimic natural behaviour. To specialists, its hyperbolic path raises suspicion but no proof. And to everyone else, it is simply a story in the background, easy to ignore. That deniability is powerful. An active signal would change everything. But silence? Silence forces interpretation. We are left guessing, arguing, doubting, and doubt is safer for the observer. What then does the comet see when it turns its instruments toward Earth? A planet in transition. A civilization young, energetic, but unstable. Nuclear weapons still bristling. Climate shifting under our own emissions. Satellites multiplying until low Earth orbit is a haze of debris. Cities glowing in the infrared. Oceans warming. Ice caps shrinking. A species that has only just begun to explore space, but already leaves scars across its own world. To an observer, the message is obvious. We are capable, but fragile. Dangerous to ourselves and potentially dangerous to others. Worth watching closely. And so 3i Atlas watches. Not by speaking, not by landing, but by following a trajectory that maximizes data without ever closing the distance. Mars for atmospheric chemistry. Venus for climate extremes. Earth for biosignatures and technosignatures. Jupiter for gravitational mapping and magnetosphere sampling. 4 encounters in sequence, each one a clean laboratory, each one a line in the report. This is why the Watcher hypothesis matters. It does not claim that this object is hostile. It does not even claim it is alive in the sense of responding to us. It claims only that its behaviour matches the logic of reconnaissance, efficient, deniable, and precisely timed to arrive when we became worth the effort. If true, then it is not here by accident, it is here because of us. If Three-Eye Atlas is a watcher, then its silence is not emptiness, it is policy. In human history, reconnaissance missions rarely announce themselves. Spy satellites do not broadcast greetings. Submarines do not surface to explain their presence. They observe, record, and vanish. The absence of communication is the point. The less revealed, the more powerful the position. The Comet fits this principle. It does not transmit, does not maneuver in ways that betray propulsion. It hides in cometary disguise. And this disguise is its shield. If questioned, the answer is always the same. It was only a comet. It was only coincidence. The evidence evaporates as quickly as its dust tail. But silence is never neutral. It forces interpretation. And in those interpretations, the real consequences unfold. Some compare it to the zoo hypothesis. In this frame, Earth is not contacted because we are under observation, like animals in an enclosure. The keepers do not interfere, they watch to see how we behave when left alone. The lesson is that we are not ready, that any direct contact would distort us, the way a human presence distorts the behaviour of a wildlife. Others prefer the laboratory hypothesis. In that vision, Earth is not a zoo but an experiment. Our actions are not merely tolerated, they are data points. Wars, climate crises, technological breakthroughs, each event logged, each variable measured. In this scenario, Three-Eye Atlas is not a messenger. It is an instrument, a sensor left behind to capture the outcome of an experiment that began long before we noticed it. Neither possibility is comforting. If we are in a zoo, then our autonomy is partial. Our decisions are framed by an invisible fence. If we are in a laboratory, then we are not subjects but specimens, and in either case the one who watches holds the power. Yet there is a deeper consequence. The watcher does not need to interfere to change us. The suspicion alone reshapes our behaviour. If we believe this comet may be observing, then every action we take becomes performance. Every test, every launch, every broadcast is weighed against the possibility that it is being recorded. It does not matter whether the probe is artificial. What matters is the change in our perception of ourselves. Already you can see it happening. Astronomers debate in private what they avoid in public. Papers describe anomalous dynamics instead of intent. But the shift is there. The vocabulary bends. The hesitation grows. The mere possibility that it is a probe alters how we do science, how we frame our own data. And if knowledge can bend science, it can bend culture. Children grow up hearing the story of a visitor that may be watching. Writers, artists, politicians, they all draw on the same image, an eye in the sky, silent but attentive. Our myths evolve, our fears adapt. This is the paradox of the watcher. It does not need to speak, it only needs to be suspected, and once suspected, it is part of us. There is another angle, colder still. What if the comet is not here to learn but to judge? Surveillance is not always neutral. In human history, reconnaissance often precedes decision. An army scouts before it invades. A corporation surveys before it exploits. The act of watching is often step one of something larger. Is that what terrifies astronomers who avoid the word probe? Not the idea that Three-Eye Atlas watches, but the possibility that its report will be acted upon. That somewhere beyond our reach, a decision will be made based on the data it carries. We do not know. We may never know. It will leave as quickly as it came, flinging itself back into interstellar dark. If it transmits, we may never hear the signal. If it carries data physically, its destination will remain beyond our telescopes. Silence will follow, as it always does, and in that silence we are left with only the consequences of suspicion. The watcher hypothesis reframes everything. It explains the trajectory not as accident but as design. It explains the timing not as coincidence but as schedule. It explains the behaviour not as confusion but as camouflage. And it leaves us with the most disquieting truth. Watchers do not need to make themselves known. Their power lies in remaining uncertain, unconfirmed, undeniable only in pattern. 3i Atlas does not have to be artificial to change us, it only has to act like it might be, and it has already succeeded. Because now we look at our world differently. We see our atmosphere not as air but as signal, our broadcasts not as noise but as evidence, our technologies not as triumphs but as vulnerabilities. We measure ourselves against an invisible audience, one that may or may not exist, but that we cannot ignore. This is the Watcher's victory, not control, not contact, influence, achieved without a word. And it leaves us with a choice. We can dismiss this object as coincidence and go on unchanged, or we can accept the possibility that we are being watched and act accordingly. But once the thought takes hold, dismissal is no longer simple. Once you have looked at the sky and asked who is looking back, you cannot unsee the question. This comet has forced that question upon us, and whether it is a rock, a relic, or a machine, it has already altered the story of who we are. There is another way to read the story, not as reconnaissance, not as menace, but as memory. Imagine an object that has been moving through the galaxy for billions of years, not for months, not for centuries, billions. Older than the Earth, older than the Sun, older even than the spiral arm of the Milky Way as we know it. Imagine something set loose when the first stars of a forgotten system collapsed, flung into space like a message in a bottle hurled into an infinite sea. That is the other hypothesis. The traveller is not a spy, it is an artifact. Its velocity tells part of the tale. 60 kilometers per second is no random number. This is not a local comet nudged loose by Jupiter's gravity. This is a speed that speaks of ancient violence, of ejection from a birthplace far away, hurled out by a giant planet or a dying sun. It has been moving ever since, its path shaped by encounters with stars, gas clouds, and the dark gravity of spiral arms. Its age, estimated between 7 and 14 billion years, forces a thought that unsettles even the most cautious astronomer. This thing may be older than Earth itself. When our world was still molten, it was already adrift. When the first microbes appeared in shallow seas, it was already passing alien stars. When the first humans looked up, it had already circled the galaxy a dozen times, and then suddenly it arrived here. If you hold to the artifact hypothesis, the coma and the outgassing are not camouflage. They are scars. The ice sublimates because the core is ancient. The dust plume is not performance, it is decay. 1 billion years of interstellar radiation has gnawed at it. Volatiles buried deep erupt when heated, not because they are fresh, but because they are fragile. What we see may not be activity in the present, but the echo of the past. The James Webb images fit this story. The unusual richness in carbon dioxide, the faint traces of nickel, the depletion of carbon chains, these are not simply chemical oddities. They are chemical signatures of an origin far older than our system, perhaps from a time when heavy elements were scarce, when stars were younger and poorer in metals. The traveller carries the fingerprint of a galactic childhood long vanished. But here is where the story grows darker. Artifacts do not always come from nature. A spearhead buried in the ground is not simply a rock. A shard of pottery is not just clay. If the interstellar traveller is an artifact, then perhaps it is debris from a civilization, one that rose, built, and perished before Earth even formed. Picture it. A world orbiting a star in the thick disk of the galaxy. A world with oceans and continents and minds capable of shaping matter. Picture a people who launch their machines into space, who fill their skies with probes, ships, maybe even monuments. And picture the inevitable. Entropy, collapse, extinction. The star dies. The system falls silent. The machines remain, drifting, battered by radiation, eroded by time, until only fragments endure. The hyperbolic visitor could be such a fragment. Not a spy. Not even functional. Just a relic, worn smooth by eons, its purpose long since erased, but still carrying the shadow of its makers. If that is true, then the object is not just passing through, it is proof. Proof that we are not the first. Proof that intelligence is not unique, nor immortal. To hold such proof in a telescope's image is to glimpse our own fate. Because if others came before, and all that remains of them are wandering fragments, then we are staring at our own eventual future. Relics adrift, long after the makers are gone. And yet there is another possibility, one that chills in a different way. Perhaps it is not broken, perhaps it is not inert, perhaps it is designed to last. What if some civilization billions of years ago solved the problem of time? What if they created probes not meant for decades or centuries but for eternity? Machines engineered to endure radiation, collisions, cosmic dust. Machines that could wander endlessly, gathering data, preserving memory, until they encountered another intelligence able to recognize them. In that frame, the traveller is not an accident, it is deliberate, a message, but one we do not yet know how to read. Its coma, its chemistry, its velocity, these are not scars of decay, but codes, signals embedded in structure. We do not yet have the key, but the key may exist. This is why the artifact hypothesis is both wondrous and terrifying, because whether the object is broken or deliberate, either way it rewrites the story of life in the galaxy. If broken, it proves civilizations existed before us. If deliberate, it proves that civilizations can reach across billions of years. Both outcomes change everything, and there is still one more twist. What if both are true? What if the makers are gone but their machine endures? What if it has outlived its architect, wandering on long after their world collapsed? Then it is not just a relic, it is a ghost. A machine without masters, carrying instructions no one remembers, serving purposes no one can still define. To astronomers, this is the real horror. Not that it is natural, not that it is alien, but that it is purposeless. A ghost machine, drifting forever, incapable of death, incapable of rest, and as it crosses our system, we become its latest witnesses, not its target, not its enemy, just another stop in its endless passage. And once again, the silence follows. It will leave us behind as it has left others before, and centuries from now, when our own satellites crumble and our signals fade, we may join the long record of civilizations erased, remembered only in relics wandering through the dark. The interstellar traveller becomes a mirror. In it, we see not just a visitor, but ourselves, projected into a future we may not survive. And that is why astronomers cannot look away. Not because it threatens, but because it warns. Not because it observes, but because it reminds. The sky has shown us an artifact, and artifacts always speak of their makers. The question is not whether it came from elsewhere. The question is, will anything of us remain to be seen the same way? The closer scientists looked, the less sense the traveller made. Natural comets follow patterns. Their chemistry, though varied, sits within familiar ranges. Water dominates. Carbon monoxide appears, faint but predictable. Organics break down into families of molecules astronomers have catalogued for decades. Even the colours of the coma, the faint haze surrounding the nucleus, fall into categories: greenish, bluish, dust red. They are the fingerprints of ordinary physics at work. This visitor refused to leave such tidy fingerprints. Take the carbon dioxide. In August, the James Webb Space Telescope trained its NIRS-PEC instrument on the faint coma. The readings were stark: CO2 in staggering amounts, far more than water. A ratio of 8:1, one of the highest ever recorded in any comet. Comets in our system tend to carry more balanced loads. CO2 sublimates quickly and is rarely dominant so close to the Sun. Here, it was not just present, it ruled. That was the first red flag. Then came the nickel. ultraviolet spectroscopy revealed faint emissions of atomic nickel. At first, this seemed familiar. Nickel and iron vapour have been spotted in comets before, including the interstellar Borisov. But this time, iron was missing. Normally, the two travel together, vaporized in near equal amounts by the sun's heat. Not here. Nickel without iron, as though some process had stripped the companion metal away or engineered the ratio deliberately. The anomaly deepened when cyanide appeared. Astronomers picked up CN emissions in mid-August, growing stronger as the comet approached the sun. Cyanide is no surprise. It's common in many comets. But paired with the depletion of carbon chains, the C2 and C3 molecules that should have been there, it painted a contradictory picture. Cyanide abundant, but chains absent. The chemistry was both ordinary and alien in the same breath. For some, this could be written off as variance. Space is vast. Comets form in different environments, shaped by the quirks of their birth systems. But for others, the irregularities whispered of something less random. Because when you see extreme abundance of one molecule, the disappearance of another, and the imbalance of paired metals, you cannot help but wonder, are we reading a message written in chemistry? Consider what a designed probe might look like after 1 billion years. It would not gleam like a spacecraft on a launch pad. Radiation, dust collisions, and erosion would coat it in a patina of age. Its surfaces might corrode into strange oxides, its inner stores of material bleeding out as gases. To a telescope it might look like a comet, but one whose spectrum was skewed in ways natural formation rarely achieves. What if the excess CO2 is not residue but shielding? Carbon dioxide frozen and layered, protecting something beneath. What if the absence of iron is not accident but choice? Iron corrodes easily in space. Remove it, and the artifact lasts longer. What if the cyanide and nickel are not just exhaust but signals? A chemical beacon activated by solar heating, designed to broadcast once within reach of another intelligence. It is easy to dismiss this as fantasy, but recall, the messenger paradox always lurks. If another civilization wanted to build a probe that could survive cosmic timescales, it would not look like a sleek machine. It would look like a rock. Camouflage is endurance. If you want to be found, you must look like background until the right eyes notice. There is also the matter of timing, woven into the artifact hypothesis as tightly as in the Watcher theory. For billions of years this thing drifted unseen, yet it arrives just as our instruments achieve the precision to pass its chemistry in infrared. It arrives just as we orbit telescopes powerful enough to see its coma redden, to detect nickel without iron, to count cyanide molecules against carbon chains. The timing is once again exquisite. Even the structure of its coma fed the suspicion. In July and August, telescopes captured a plume pointing toward the sun rather than away. A plume is expected. Heat drives out gassing on the sunlit side, but the shape was unnerving. The plume was narrow, persistent, unlike the diffuse sprays seen in ordinary comets. By late August, an anti-solar tail had formed, but the plume remained stubbornly present. To some eyes, it looked less like evaporation and more like venting, controlled release. Add these anomalies together, CO2 excess, iron absence, chemical contradictions, sun-facing plume, and the natural story begins to feel stretched. Each explanation requires qualifiers. Maybe the nucleus is unusually insulated, maybe water sublimation is blocked, maybe metals fractionated in exotic conditions, maybe the plume is just geometry. Maybe piles on maybe. But if you invert the frame, the data flows differently. Instead of strain, there is coherence. Instead of piling in probabilities, the anomalies align. The traveller looks engineered, and that raises the most dangerous question of all. Engineered for what? Was it built to observe? If so, then the plume might be more than venting. It might be propulsion, tiny bursts to stabilise orientation. Was it built as a message? Then the chemical excesses are not accidents but codes, compositions arranged to flag attention. Was it built as a monument? Then its survival across 10 billion years is not coincidence but design, the success of an intent to outlast death itself. Of course, there is another reading, one no less unsettling. Perhaps it was not meant to endure this long. Perhaps its makers are long dead, and what we see is a probe in decay. The shield is cracking, the code's corrupted, the structure's leaking their insides into vacuum. What we read as signal may simply be noise, the last breaths of a machine with no masters left to care. That is the paradox of the artifact. Whether functional or broken, it still speaks. A shard of pottery is still proof of a culture. A rusted spearhead still proves the existence of hunters. Even if the interstellar traveller is nothing but cosmic debris, it testifies to hands that once shaped it. Astronomers argue fiercely over these interpretations. Most cling to the natural explanation. Extraordinary claims require extraordinary evidence. But the minority who entertain the artifact hypothesis do so with the weight of history on their side. Every age has dismissed the impossible until the impossible arrived. Every age has mistaken artifacts for accidents until closer eyes revealed the maker's hand. And so the traveller drifts on, trailing questions behind it like dust. A relic, a machine, a ghost. No one can yet say. But as long as it burns across our skies, it forces us to ask what kind of galaxy we live in. One where we are alone, and this is just rock and ice? Or one where relics of the long dead drift between stars, waiting for new minds to wonder at their purpose? If it is artifact, then we are not the first. And if we are not the first, then the silence of the galaxy is not empty at all. It is full of ghosts. When a strange object crosses your skies, discovery is only the beginning. The harder question comes next. How do you respond? With 3i Atlas, the first debates were not about what it was. They were about what to do. Within hours of confirmation, international agencies convened quiet calls. SETI researchers, planetary defense coordinators, even military liaisons, all drawn into a conversation with no precedent. A visitor from another star had arrived. Every decision, from telescope time to public statements, carried consequences. There is on paper a protocol. In 1989, the International Academy of Astronautics drafted guidelines for post-detection procedures. If an anomaly is found, you confirm it independently, notify the scientific community, inform governments, and release information to the public. The idea is transparency, no secrecy, no panic, no unilateral moves. Humanity speaks as one. But paper protocols falter against reality. In practice, the channels are fragmented. NASA has its priorities, ESA its own, China its own. Militaries view the sky through threat assessment, not curiosity. Civilian astronomers value open data. Governments guard national advantage. By the second day of 3i Atlas's discovery, classified meetings had already begun. Was this a comet or a probe? If it was artificial, could it listen? Could it transmit? Could it maneuver? If it could, was it safe to aim radar beams at it, or would that reveal too much? Silence, ironically, became policy. Telescopes observed, but carefully. Data was shared, but not fully. Public press releases emphasized unusual cometary activity, while avoiding the darker questions. Behind closed doors, agencies wrestled with a dilemma as old as humanity itself. Do you announce the unknown, or do you control it? This tension is not new. When Oumuamua appeared in 2017, similar debates unfolded. The Harvard astronomer Avi Loeb argued publicly for the artificial hypothesis. He was criticized, sometimes ridiculed. But behind the scenes, his suggestion forced agencies to consider what they would do if he were right. The uncomfortable truth is that no one had an answer then, and no one has an answer now. Because the question is not simply is it natural or not. The question is, what does our response signal? Game theory looms large here. If the traveller is artificial, it may be designed to observe not just our planet, but our behaviour. Do we approach openly, broadcasting signals and data? That could prove we are curious, cooperative, ready. But it could also expose us, our technologies, our capabilities, our vulnerabilities. Do we stay silent, pretending not to notice? That avoids risk, but it also makes us look blind, timid, perhaps even deceptive. Every action is a message. Even inaction is a message. Consider radar. The Goldstone Deep Space Communications Complex has the ability to bounce signals off passing objects. With 3i Atlas, the decision was debated. Illuminating it with radar would return high-resolution data about its shape and surface, but it would also announce us in the most direct way possible. A beam of artificial energy, unmistakable to any receiver. Was that wise or reckless? Consider messaging. Some argued for a deliberate transmission, a simple broadcast, a mathematical greeting, aimed at the object as it passed. Others countered that we already broadcast enough. Television signals, planetary radars, space probes, all leaking into the void. Why shout when you have already whispered for decades? Even transparency became a trap. If scientists spoke too openly about the probe hypothesis, they risk panic, or worse, political appropriation. If they stayed silent, they risk ceding the narrative to conspiracy and speculation. Either way, the public would draw conclusions, and governments would act on them. The result was paralysis. By the end of July, humanity had not agreed on a response. Observations continued, papers circulated, but the central question, how do we answer, remained unanswered. This paralysis is not unique to astronomy. History is filled with first contact dilemmas. When explorers reached new shores, their choices shaped centuries. To trade, to conquer, to ignore. Each decision altered the future. But here, the stakes are galactic. There is no precedent. There is no safe model, and time is running short. Because the comet is moving fast. Within months it will be gone, accelerating back into interstellar dark. Whatever choice we must make it quickly. A window of opportunity measured not in centuries, not even in years, but in weeks. And so the dilemma sharpens. Do we risk signalling too much, or risk signalling nothing at all? One fact presses hardest. The object broke 3 rules: trajectory, timing, behaviour. If it is artificial, those breaks were deliberate. If it is natural, then our response may be irrelevant. But if it is not, if it is designed, then our silence or our speech may matter more than we can imagine. That is the weight behind every closed-door meeting, every cautious phrase in public releases. Not fear of the unknown, but fear of the consequences of being noticed. The response dilemma is no longer theoretical, it is unfolding in real time. And for the first time in history, humanity is not asking what is in the sky. But what do we do about it? By August, the cracks were showing. On one side, civilian astronomers pushed for openness. The data belongs to everyone, they argued. If this is natural, transparency will prove it. If it is not, secrecy will only deepen distrust. Journals prepared papers describing chemical anomalies, strange trajectories, faint plumes. But in the footnotes, in the emails between colleagues, the word no one wanted to print kept appearing: probe. On the other side, governments tightened their grip. Radar sessions were postponed. Certain spectra were withheld from public release. Observations were classified under national security just as quickly as they were made. The logic was simple. If this object was artificial, then whoever held the best data held an advantage. Information became territory. The divide was not just political, it was cultural. The United States feared being outpaced by China. China suspected the West of hiding breakthroughs. The European Space Agency insisted on cooperation, but lacked leverage. Russia lurked at the margins, neither transparent nor silent, always hinting at knowledge unshared. Each power saw not a cosmic visitor, but a stage on which to project its own insecurities. The irony was brutal. If the object was a watcher, it was learning more about us from our response than from our planet. It did not need to intercept signals or analyze atmospheres. It only needed to observe how quickly we fractured under pressure. Meanwhile, the public filled the silence. Forums, podcasts, fringe media, all speculated freely. Some believed the visitor was benign, a gift of knowledge waiting to be opened. Others saw it as an omen, the first step in an invasion. In the absence of clear answers, certainty grew loudest where evidence was weakest. And every theory, no matter how outlandish, carried weight simply because the official story refused to commit. This was the response dilemma in practice. By trying to control the narrative, authorities surrendered it. Yet beneath the noise, one truth remained. Every possible reaction carried risk. If we signal, directly, deliberately, we admit presence. We declare readiness, even if we are not ready. We show unity, even if unity is false, a bold move but reckless. If we remain silent, we project fear, or worse, irrelevance. We become the species that noticed a probe and did nothing, paralyzed by our own divisions. Silence is not neutral, it is surrender dressed as caution. Even the attempt at balance is dangerous. A weak, inconsistent signal tells more about our confusion than about our caution. It says we are aware but indecisive. That may be the most revealing message of all. This is the trap. The object forces us into a decision tree where every branch carries consequence. Inaction is action. Silence is noise. Restraint is exposure. And so the central question deepens. The visitor may not threaten us directly. It may not fire, signal, or approach. But by its very presence, it demands a choice. And that choice may matter more than any calculation of velocity or chemistry. What makes the response dilemma unbearable is not the object itself, it is the mirror it holds up. 3i Atlas, whether natural or not, has already shown us what we are: divided, cautious, competitive, fearful. It has already extracted the most valuable data point imaginable. Not about our atmosphere, not about our oceans, not about our radio signals, about us. In every negotiation, every delay, every redacted paper, it learns the truth. Humanity cannot yet speak as one, and that, more than trajectory, timing, or chemistry, may be the most dangerous revelation of all. Because if this object is a probe, then our first message has already been sent, not by a transmission, not by a broadcast, but by our behaviour. And that message is simple. We are not ready. The object will leave. That much is certain. Within months it will fade beyond our telescopes, another point of light swallowed by the dark. It will not slow down. It will not turn back. Whether it is comet, relic, or probe, it will vanish into the silence from which it came. But its passage has already left something behind, not dust, not molecules, not data. Something harder to measure, yet impossible to ignore. A change in us. For centuries we have stared at the stars asking whether anyone else is out there. The answers have always been abstract. Numbers on chalkboards, probabilities and equations, speculation framed in cautious words. But the third interstellar visitor has forced the question out of abstraction. It is no longer theory, it is confrontation. A foreign traveller has crossed our system, and in its wake, humanity cannot return to who it was before. The transformation begins quietly, as it always does. In observatories, scientists find themselves speaking differently. The old categories, asteroid, comet, interstellar debris, no longer feel complete. Papers begin to hedge less, risk more. Words like unprecedented, anomalous, extraordinary slide into mainstream journals. Younger researchers, less scarred by ridicule, speak openly of the probe hypothesis, and with each passing conference the taboo weakens. At the same time, the silence of governments becomes louder. The classified sessions, the redacted data, the delays, these are no longer bureaucratic quirks. They are proof that the visitor has entered the realm of geopolitics. Space is no longer just exploration or defense, it is negotiation. Any object from beyond is now a potential actor in world affairs. The laws are not ready. The protocols are not ready. And so, committees begin to draft new ones. Conferences once devoted to planetary defence now include panels on non-terrestrial contact contingencies. Lawyers argue over who owns data on an object that might not be natural. Philosophers debate whether silence counts as a response. But the most profound change does not happen in institutions, it happens in imagination. Children draw pictures of the traveller in schoolbooks, not as a comet, but as a machine. Writers spin stories of silent probes circling distant stars. Musicians compose pieces named after its catalogue number. The idea enters culture as myth, and once a myth takes root, it cannot be uprooted. The sky is different now. Every streak of light, every new discovery is coloured by the suspicion that we are being seen. The overview effect, once reserved for astronauts gazing back at Earth, now extends to all of us. We have felt the weight of an interstellar gaze, real or not, and it alters perspective. Wars, politics, borders, these seem small when set against the possibility of watchers older than our species. For some, it inspires humility. For others, paranoia. But for all, it creates a new frame of reference. Humanity, not as nations, but as one data point among many in a larger experiment. It does not matter whether the object was natural. The suspicion alone has done its work. Like the zoo hypothesis, like the laboratory frame, it changes behaviour simply by existing as a possibility. We act differently when we think we are observed. We build differently. We speak differently. Even in doubt, we adapt. Already, research funding shifts. Proposals for new survey telescopes emphasise not just planetary defence, but interstellar detection. The push for faster probes, craft capable of chasing anomalies before they vanish, gains urgency. What once sounded like science fiction now receives line items in budgets. Engineers designed for the day when the next traveller arrives. Because it will, and when it does, we intend to be ready. Culture, science, politics, all bend toward a single axis. The recognition that we're no longer alone in the void, even if the evidence remains ambiguous. The visitor did not change the laws of physics, it changed the laws of perception, and perception is enough. The real transformation is subtle, but irreversible. We are no longer the species that wonders if the galaxy contains other minds. We are the species that has begun to behave as though it does. That shift cannot be undone. And so, the traveller becomes part of our story, not as comet, not as artifact, not as probe, but as catalyst. A silent force that, by passing briefly through our skies, forced us to confront who we are and who we might become. The object will leave, but the transformation has already begun. The night it was discovered, astronomers spoke of numbers, velocities, inclinations, eccentricities. Equations sketched the impossible arc. Reports carried the sterile tone of science, anomaly, confirmation, designation. Yet behind those words, another current ran, a sense that something had shifted. Months later, as the object fades into distance, the numbers remain. But what lingers most is not data. It is the questions it left behind. Why did it break the rules? Why did it arrive now? And why did it act like something more than rock and ice? The official answers are cautious. Unusual cometary behaviour, extreme interstellar fragment, unexpected chemical ratios, safe words, words designed to protect careers, to protect institutions, to shield against ridicule. But outside the walls of academia, the language has already changed. For the public, the story is not about carbon dioxide or hyperbolic excess velocity. It is about intent, about the possibility that something out there knows we exist. This is the first transformation. We no longer assume the sky's indifferent. The second is subtler but more profound. The traveller forced us to confront ourselves. How we fractured, how we hesitated, how we let politics shape discovery, how quickly secrecy rose where openness should have stood. The object revealed not only its own anomalies but ours. In a sense, it held up a mirror, and the reflection was not flattering. Yet there is a third transformation, one that carries hope. For all our divisions, for all our hesitation, the encounter has already seeded something new. More telescopes will rise, more probes will launch, more minds will dare to speak aloud what was once unspeakable. The silence of the galaxy no longer feels absolute, it feels like the pause before another knock at the door. And in that pause, humanity prepares. Some prepare in fear, stockpiling defences, whispering of an invasion. Others prepare in wonder, sketching designs for missions that could chase the next visitor. Still others prepare in silence, letting the thoughts settle into culture like sediment. We may not be the first. We may not be alone. We may not be the last. The traveller itself does not care. It moves on, indifferent, or perhaps purposeful in ways we cannot decode. Its coma fades. Its tail thins. Soon it will be invisible to all but the deepest instruments. It will vanish as the first two did, another ghost swallowed by infinity. But unlike the first two, this one leaves a scar. Oumuamua was anomaly, Borisov was confirmation. This one is catalyst. It broke 3 rules and in doing so broke something in us. The certainty that interstellar visitors are mere curiosities. That certainty is gone, replaced by something harder, sharper, a tension between dread and possibility. This is where the detective story ends. Not with a solved case, but with a file left open, its pages still warm with unanswered questions. Was it artifact, probe, relic, comet? The evidence never resolves, but the act of investigation has changed the investigators. We began with 3 rules: random path, coincidental timing, ordinary behaviour. We end with 3 transformations. The sky no longer feels neutral. Humanity no longer sees itself the same. The future no longer feels closed. Perhaps that is the purpose of visitors like this, not to reveal themselves, but to force us to reveal ourselves. And so, the case of 3i Atlas closes, not with certainty, but with awakening. We step back from our telescopes, turn away from the desert domes and orbiting mirrors, and carry the question inward, into our politics, into our culture, into our myths, into the way we raise our children, the way we look at each other under the same night sky. Because now we know the silence is fragile, the void is not empty, and every time we look up we must ask not only what is out there, but who might be watching back. This is the legacy of the third interstellar visitor, not its dust, not its data, but its shadow across the human mind. The object will leave us, but we will never leave it.